Before we go into the integration techniques by partial fractions, we need to understand how fractions, algebraic fractions, work, in particular when we add them. If we had 3 over x minus 1 plus 2 over x plus 4. Now, in order to combine those two into a single fraction, you use the same rules as if it was 3 over 4 plus 2 over 5. We've got to make the denominators the same, and with these algebraic denominators, it's probably best off by just multiplying by the other denominator. So we can rewrite the first fraction as 3 over x minus 1, and then if we multiply the bottom by x plus 4, the other denominator, if we multiply the bottom by that, we've got to do the top or the numerator by that as well, x plus 4, plus, now our whole quest here is to make these the same denominators. Presently we've got 2 over x plus 4, so we've got to multiply by an x minus 1, top and bottom. Equals, when we multiply out the denominator, we get x squared, the inner plus the outer, minus 1x plus 4x gives us a net result of plus 3x, and then minus 1 times plus 4 is negative 4. Remove the brackets, so it's all of this plus all of that. So we've got 3x plus 12 when I multiply by there, plus 2x minus 2. Collect like terms on the top, the denominator stays the same as x squared plus 3x minus 4. Collect your x's together and you get 5x, then plus 12 minus 2 is plus 10. Okay, so that's how to combine partial fractions. So if we were asked, partial fractions is starting with here, when you've got the single fraction and you've got to break it up into its parts. So if you like, it is a reverse of that. So if we were asked to do the integral of 5x plus 10 over x squared plus 3x minus 4 dx, if we could break this up into its parts, in other words, if we, and we will, we'll devise a method for going from there back to there, we could say that is equal to the integral of these two. And you can do the integral of the individual parts. And this is simply the integral of 1 over x minus 1 is ln x minus 1, so that'll be 3 ln the absolute value of x minus 1 plus 2 ln x plus 4 and plus our constant of integration. So that's what we're going to attempt to do, is to come up with a process where we can actually split this into its individual linear fractions, and then hopefully these we can use a method, whether it be substitution or completing the square, whatever. We'll come up with a method and hopefully be able to do the integrations. These are just linear ones, straightforward ln. So that will be our approach from here on.